This video is here to help you with the progression assignment task 1. Hopefully by now you have gone to my YouTube channel and watched all the videos relating to bijunction transistors, and hopefully you have also watched the progression video introduction which explains the brief. Now, assuming that you have done that and you have also gone to Electronic Tutorials website and read about the bijunction transistor, then you will now be ready to build the circuit diagram that will help you explain how a bijunction transistor works in relation to the base. So a bipolar junction transistor has 3 pins. It has a collector, a base, and an emitter. So here we can see a bijunction polar transistor with the 3 pins, 1, 2, 3, the first pin being the collector, the second pin being the base, the third pin being the emitter. Now, bipolar junction transistors, or BJTs, come in NPN and PNP types. You will need to research and understand what the differences are between these two types of transistors. So this type of transistor is essentially being used as a switch. Now, bipolar junction transistors work by amplifying the base voltage across the collector and emitter. So as the voltage here rises, the voltage across the collector and the emitter also increases, meaning more power gets to this LED. Now, this principle of the transistor is what allows us to use it as a switch. A bipolar junction transistor is a progressional switch. It's not just on or off, it's on and incrementally increases its voltage until it is fully activated. So in this circuit here we have a DC power supply set to 9 volts, as well as 2 resistors. This one here set to 8000 ohms, this one here set to 330 ohms. We have our LED, our transistor, and here we have a potentiometer. The potentiometer is going to allow us to vary the voltage here at the base pin. Now, there is a video tutorial on how to get started with Multisim Live, which is the software I'm using. It's a web-based software which you all have access to. That tutorial can be found on either Teams or it can be found on my YouTube channel. You will need to watch that tutorial to fully understand what it is I'm going through during this tutorial. So this is the circuit that we're aiming for. Now what I'm going to do is I'm just going to use Control left click and select the whole circuit and just move it to one side so that we can work here and rebuild that circuit. So we need to start off with a power supply. So on the left hand side I'm going to go to sources and I'm going to select a DC voltage. I'm just going to place that down here and rotate it round. Then I'm going to grab some resistors from our passive components here. So passive components are those that don't produce any output, they just affect voltage and current flow. So I'm going to place one here, I'm going to copy that and place it down here and rotate it round. Now if I double click on the resistor, I can change this value here. I'll change it to 330 ohms, click this one, change that to 8K, which is 8 kilo ohms. So now I'm going to grab an LED, I can find that from the diodes. There we go, got my LED. I'm going to place that down. And my transistor, which is an NPN transistor, can be found under the transistors. Let's place that down as well. Finally, the last component I need is a potentiometer, which essentially is a resistor that has a variable resistance. So we're actually able to change the resistance of this component, changing how much current it restricts and how much voltage it restricts. Placing that down. Okay, so now I'm going to go ahead and connect all of these up as above, just by clicking on the node of the component and then clicking on where I want to connect it to. Yep. You might find it easier to zoom in for this. Now it doesn't matter if it's not too neat, we can move it around and rearrange it later. I'm just going to continue to do this now. Alright, so I've now got all of those connections in place, just like the top circuit. Now the second example isn't quite as neat, but I'm just going to leave it how it is for now. The last thing I need to do is add a ground. This is for simulation purposes, so that the software knows exactly what we're using as the negative return. So I'm just going to add that ground down there to the bottom. Now, what we should find is if I run this simulation, okay, just pushing the play button at the top there, this LED comes on, and if I select the percentage down here, I can slide that down, and as I reduce that, at some point the LED should turn off. Okay, so the LED is now off. As I increase the potentiometer, we can see the LED starts to get brighter and brighter until it is then fully on. Now what's happening is we have a voltage coming through here into our potentiometer, and that voltage is being split. Some of that voltage is going to the base pin of our transistor, and some of that voltage is going down to ground. By adjusting the percentage here, by adjusting the potentiometer, we're actually changing how much voltage flows down each path. Now this is what a potentiometer looks like. This is a standard looking potentiometer. They do come in a variety of shapes and sizes, but this just gives you an idea. You've got 3 pins here, 2 outputs, 1 input in the middle, and as you twist or rotate this pin, it changes the resistance across each path. So its potential difference changes, changing the current and voltage flow down each path. So essentially we're using it as a sort of electronic valve. So back to our simulation, it's all well and good that I can change this percentage and I can see the LED turning on and fading on and becoming fully on, but that doesn't actually give you much information. So what I want to do is pause or stop that simulation for a moment, and I'm going to add a voltage probe. A voltage probe will allow me to monitor the exact voltage going to the base, and I can find out exactly at what voltage the LED turns on. Alright, so I've now got that probe placed, it's connected to the line, and if I run the simulation again, and I'll get a voltage value here. So the voltage at the base pin, or the base emitter voltage, is 865 millivolts. Now this is around 0.865 volts. Okay, so you always have to be careful with the unit. You have to make sure you understand what unit you're in. Now if I adjust the potentiometer again, okay, we should see that that voltage decreases. So the resistance of the potentiometer is increasing along this path, therefore the voltage is decreasing. Now there come a point where the voltage will drop below the activation voltage of this particular transistor and the LED will turn off. What we want to do is try and determine that voltage, okay, which will take a bit of trial and error, so I'm just going to find out what that threshold voltage is now. Okay, so at 700 millivolts, the LED is off. If I increase the voltage there, above that you can see that the LED starts to turn on at this point. Okay, so it's gradually getting brighter and brighter in this simulation. And I'd probably say it's fully on at about 834 millivolts. Okay, if I increase that now, it doesn't get any brighter. So that's when it's fully on, or the transistor is fully active. So what's happening when the voltage on the base increases is that electrons within the silicon, within the NPN transistor, are rearranging. The depletion region, which you should find information about in your research, is decreasing, and the two sides of this transistor are essentially being joined together, creating one conductive path. If the voltage at the base decreases, the depletion zone within that transistor increases, creating a barrier, essentially a break in the circuit that prevents the electrons from this side flowing through to this side, breaking the complete circuit, preventing electrons from flowing through the LED and back round to the power supply. That means our LED is off. So you need to use this simulation to explain about the base emitter voltages, how a transistor can be used as an amplifier and a switch, and you also need to look at how the silicon within the transistor is changing to allow the transistor to become conductive and non-conductive. Now, looking at the semiconductive nature of the transistor is something that you can do by watching a few YouTube videos, which are very good and go into some really good detail, and you can find those under the transistor playlist on my YouTube channel. If you need to find my YouTube channel, you can use one of the links on Teams or just type Carl Swithenbank into YouTube. That's the name of my channel, nice and easy. Hopefully you'll be able to build this circuit and use it to help you explain about this transistor and how it works, looking at the activation threshold here of the base pin, explaining at exactly what point it turns on and when it turns on. So when we have the sufficient voltage here, what's actually happening within the transistor during that time to allow the collector and the emitter to become conductive.